Hello everyone, in this video we are going to learn resistors in series. Let's start. Consider a resistor R1 is there, another resistor R2 is there. So one end of this is connected to one end of this. So end to end connections are called as resistors in series. So let's take this is connected to a cell of V volt. Okay, let's take this point as A, B, C, T. Try to understand what are the key points you should remember. In a series combination, current is same. So whatever the current is passing through this cell, okay. So here I current passes through R1, same I current passes through resistance R2. So first point you should remember is what? Current is same, I is same. Okay, and here potential divides. If V volt is given, so whenever I current passes through R1, so there is a potential drop across this, that is what? V1. Whenever I current passes through R2, there is a potential drop across this R2, that is V2, according to the Ohm's law. Yes or no? So here what is important? V is equal to V1 plus V2. These 2 points you should remember. First point is what? End to end connections are what? Series connection. Second point, current in a series is same. Third point, potential divides. Okay, so we are going to derive an expression of equivalent resistance when two resistors are connected in series. They may give you for 3 resistance also. Okay, so we are doing here for 2 resistance. Now if you want to know what is V1, that is potential drop across R1. Okay, so you can write a potential drop across R1. Okay, R1, what is the potential drop? V1. V1 according to the Ohm's law, what is that? Current into resistance. Current is I into R1. Similarly, potential drop across resistance R2. Okay, what is that? V2. V2 is equal to what? I into R2. Let's take this equation 1, equation 2. This I have considered as equation A. Now I want the equivalent resistance. What do you mean by equivalent resistance? Equivalent resistance is that value of resistance, okay, which will produce the same effect as produced by the 2 resistor in series. Okay, so here I have taken an equivalent resistance RS connected to the same cell of V volt. Okay, so when current will be same only, right, because source of current is same. So I current passes through RS, so there is a potential drop across this, so we can write a potential drop across RS, that is nothing but V is equal to current into RS, current into RS, that is equation 3. Now what we are going to do, we are going to substitute equation 1, 2, 3 in equation A. So we can write using equation 1, 2 and 3 in equation A. So what is equation A? V is equal to V1 plus V2. What is V here? V is equal to I into RS. Yes or no? So I into RS. What is V1? V1 is nothing but I into R1. I into R1. What is V2? V2 is nothing but I into R2. Yes or no? Now you can take I common. I into RS. Here you can take I common. So R1 plus R2. Here I get cancelled. So we are getting finally as RS is equal to R1 plus R2. RS is equal to R1 plus R2. So when we talk about series combination, to find the equivalent resistance, we have to just add the individual resistances which are connected in series. Okay, one more point you should remember, the equivalent resistance which we will get will be always greater than R1 or R2. Yes or no? Because it is a sum of the 2 resistors. Is it clear? Okay, if suppose 2 equivalent resistance are connected in series, okay, so suppose R is there and R is there connected in series. So what is the R equivalent? Okay, RS is equal to what? R plus R, that is equal to 2R. Yes or no? Similarly, if n such R resistors are connected in series, okay, R, like that n times is there, n times is there, okay, connected in series. So we will get the R equivalent, that is RS is equal to n times of R. Is it clear? I hope you understood these concepts of resistors in series. Thank you.